Hello there. Welcome to the next tutorial video. Today we're going to be covering animations, which are fun. So I'm just going to open up the project. This is a fresh open. Nothing's changed. Obviously I haven't opened up any files. But another thing that I'm going to do is I'm going to drag this folder in here and we're going to go into the assets. We're going to go into sprites and you'll notice we have a sprite sheet in here. This wasn't there last week, and you'll also notice we have this. Now, all this is it's just a list of frames and stuff. I am including a few PDFs within all of our work and everything. So these allow you to create. This is how you create your own like sprite sheets and like set them up properly so that you can use them within the framework. This is a step-by-step process, and then you can download the actual data from the website, set this up, and then import the animations like this. Today I have a JSON that I've already written using this, which I will probably also upload. This is just creates a JSON that can be loaded into the framework instantly. So all you gotta do is put in the x1, y1, so 165 and then 65.1. But yes, so like you will notice the first one is at, so this is frame 5. So frame 5 starts at 265. It moves over 64, so it's 329. This one starts at 65 and moves up 64, which means it's at 1 pixel. Because the Y's are flipped. So in an image, and we can open up Paint and look at that. Sorry, this is just a lot of like preamble to starting. So if you look at Paint, and if you look down here, this tells me exactly where my pixels are. As I go up, the Y value goes down because the top of your image 0, 0 is right here. Right here. 0, 0 is this corner. As I go down, Y increases, and as I go right, X increases. See? X is increasing and decreasing as I go right and then left. And then Y is increasing and decreasing as I go down and up. That's all. That's all I wanted to make sure to mention for this. So that's needed because and I'm going to tell the task earlier in this video. Specifically, your task is going to be to create your own sprite sheet, or you can like edit an existing one. Just make sure to follow these steps because there's going to be a quote-unquote glitch in today's animation, and your job is to basically either take the sprites, because I understand not everyone's an artist. I'm no artist personally. I took this sprite sheet from online, but I manually made this using the JSON creator, but I found this online. So I opened this up in, so the way that I did this using an existing one is I did right click, open with paint.net, and then I manually selected each and every one of these. And so you'll notice that your selection, the top left of my selection is 7361. Or sorry, no, it's 1411. And then you can just select down here, so then it's 30 or 29, 33. Or sorry, here's the bottom left. Because we're doing, so you need the bottom, I believe, wrong thing. If we're looking at this, I don't want to give incorrect information, so I'm going to make sure. Oh, this is the wrong one. There's also a second one I should mention. There is a second. This explains how animations work within the framework. So you need the top left and bottom right. Wait, I was right. You need the top left and the bottom right. So in paint.net, if you look at the thing down here, yeah, here it is. The top left of it is 1411, and then the size of it is 16 by 23. So that means 1411 all the way over. So it is so 14 plus 16, and then 11 plus 23. So 30, 34. So 30, 34. And if we go in, I believe this is my run. If we go into my thing here, if we go into configs, and we go to walk left. Also view, there it is, toggle word wrap. Sorry, this doesn't look good because this is before I made these JSON files aren't like formatted to look good. They're just formatted to exist. So if you look, frame 0, walk left. Frame 0, walk left. 1411. So it's dang it. This thing. So we need to figure out what the bottom left. Oh, I was right. So you get the top left and the bottom right, and then you need to figure out what the bottom left and the top right are. So you literally just can flip these. So to get that, so we take our top left, 1411, add it to get 3034. So our bottom left value is 1434, and our top right value is 3011. The reason why we need the bottom left and the top right is because that is needed to specifically choose where an image goes. And this just makes it so you never have to give all 4 of them. Now technically you can easily just go in and check. Like you can first start checking, but notice how it's 1134 and then oh, didn't mean to unselect it. So you look down here. Yeah, I believe I cut this off by accident. I believe it's just this, because I did. It's 32. Right here, I wrote 32 instead for the top right. Yeah. Yeah, that's okay. Either way, the point is that I will. This is a lot of numbers. Don't pay attention to this. I know this sounds rambly. I apologize. Not meant it to. It'll make sense when we actually load them in. And if you like actually go through this, which will be required reading. This is very much required reading. It's not nearly as big as it like seems to be, but just pay attention to these things. Watch it. So like for example, if I click on this link actually, you'll notice that Link stretches. He moves. Link moves and sometimes stretches weirdly when he attacks. The reason for that is because it's not centered. So you need to center your animations. You got to center them properly. But yes, now to the content. I will close these. These are uploaded. These will be available along with everything else instantly. I'm going to close that. I'm going to close this, leave this open. Now we're going to do our usual song and dance. Going to open up game.cpp, bin it. Now today we have multiple to open. We have to open up Animate Sprite Playground, H and CPP, but we also have to open up player.h, which is a new file that I added, and player.cpp. Now also I should mention, if we run it, it's going to run our old scene, Physics Playground. You know, I should mention this one also won't be an hour and 30 minutes. There's actually really not like a whole lot to get done for this specific one. It's relatively simple. Oh, sorry. Apologies. I should put my phone on vibrate. But this one isn't specifically like, it's not specifically hard per se. But yes, there's really not like a whole lot to get done in this one. I'm just waiting for this to build. It's got to take a bit to build. See? Same as last week. This is the one we did before. Sprinting and physics. Yeah, that's it. So we are going to get started with this. So I've already made all the required things that you need. And so what we're going to do is we're just going to make this possible to build. We're going to make this a scene that exists. So what do we need to do? Well, I mentioned last time that we have to make an initializer list. And then obviously I'm going to leave this comment in like every single time. Gravity. So this is just me. I'm just setting the physics world gravity. We already know about all this. We've already done the gravity. As I mentioned, there may be some like disconnects between last tutorial and this tutorial, as this tutorial was meant to happen before physics, so we won't be using physics bodies in this one. Your task will have you combine them together though, as that's something you will need to do for your assignment. So I just want to make sure you guys are steadily doing your assignment as you go through things. So, you know, just the typical, like, you know, startup stuff, ECS, attach, register, scene reg, and then float. Window height. There you go. And then set up main camera entity. Create camera. And then don't forget to make it the main camera. And then we're just gonna, so if you wrote those functions that I mentioned, the ones that allow you to just instantly have these done, you could just write those. However, because I didn't write those with the class, and I have those in another file, I'm going to be going through these regularly. If there's enough like want for us to write them like as a class, I could possibly write them during. We could write them all together. Those functions that allow you like, you know, scene, you know, create camera entity, you know. Oh, I did create that. I actually created this. Yeah, we created this during the. I forgot that we made this. We wrote this during the Q&A session. Last week. So yeah, we did. We did indeed do that. And that is, yeah. So create camera entity, stuff like that. Technically, I could just write that here. I could theoretically just write. This is something that we wrote in the last thing, but I won't, not this time. But I may put out a separate video just explaining how to do those. This way, if I ever do them in a future video, which I probably will, this way I can just refer to that video that I made. And if anyone asks any questions about how to do it and why I use this function and why they don't have it, which by the way, everyone should have that function within their thing. I'm just trying to get in this good practice. Because this is the starter. This is the same. I'm using the same starter that you guys got. Haven't written a single new line of code in it since I updated it, uploaded it to Canvas. Set ortho size, get component, camera, entity, set window size, vec2, float, window width, float, window height, and then entity orthographic. Aspect ratio, aspect ratio. Sometimes IntelliSense messes up like that, and I just typically delete the entire line or the entire word to make sure that it'll come back. temp.w, -100.f. And then we also want to horizontal scroll. Set cam. Get camera. I just copy paste it because you can just do this. There you go. That's our camera entity. Now, we're going to add back hello world sign. And these comments that I leave at the top specifically are just so you can control F through your code when you have a lot of entities. I leave comments about what an entity is, like what it's meant to be, just so I can control F later on. Like this way I can just hover over this, go right here. That brings me to this. It's just not big enough to actually move me. Now we just got to create entity, attach component, sprite, attach component. Remember that any basic entity or any basic sprite like entity requires a sprite component and a transform component. And then we load in the sprite. Now you could easily just have a single thing to do this. That'll do it really quickly for you. Same as I have for the camera. Or you can write it by hand. Typically, you don't ever want to be writing repeat code. So I would highly recommend writing functions that do it for you. I'm going to make it like 80% transparent. And then transform. Set position. Vector. And that's all. So, next up, we're going to create our player. So, set up link. Auto entity, create entity, set as main player, true, ECS, attach component. So first we want to transform. Well, first, we're going to follow the same sort of rules as we've done the last little bit. So sprite first, attach component, transform. Now we want this to be an animated character. So we have a new type to add. Animation controller entity. So this is really interesting. All it does is basically store a bunch of these animation objects and allow you to just create everything. And here's why we get the bottom left and the top right. So this is how you create a UV coordinate. It just initializes all the numbers. That's it. That's all. That's why we need the bottom left and the top right. That's all. And when you're adding a new frame or adding a new animation, so animation stores the UV coordinates as well. So you can add a frame and it gives you the UV, you just pass in the UV coordinates, or you can add in just a vec2. So technically you can actually create your own UV coordinates. You don't need to theoretically, just use bottom left and top right. I would recommend it though, because that's how this thing is built to work. That's how this separate one is built. So yeah, the only issue is this is kind of ugly. It's kind of ugly. So we are going to attach a new component that we're going to create today. Because this is our main player, it gets special treatment. I don't know why this entire line is messed up. Weird. Did I attach component? Attach component. Player. Oh, that's another thing we forgot to do. So if we go to backend.h, what? You'll notice the player is included. Interesting. That's it. You can't include anything from backend.h. This should work. Now if I write, yep, there you go. Apologies, I wasn't thinking. But now, so we're going to attach our player component. Now, this player component doesn't really do anything yet. We haven't implemented the stuff. So we're going to set up components here. And we're going to leave that blank. One thing we do know, though, two things that we do know. std string file name, it's spritesheet/link.png. That's where I keep the sprite sheets. And then animations. So in this case, we're loading in an animation file. Otherwise, you wouldn't pass just an animation file. However, this is made to pass animation files, so you do want to be making this a thing. You do want to be passing. You do want to be using. Let's see if I can find it. Okay, I currently do not have it, I believe. Oh. No, I do not have it with me right now. I don't have it on this computer because it's a new computer. But I'll show you guys. I will see if I can't download the yeah, I'll like I've already put the tutorials on, you know, using the animation creator on up here. These are all like, they're just words, not videos. These are all screenshots and stuff like that. These will all show you exactly how to use the animation creator, as well as how to use animations within this. Same as this video is going to show. However, that one goes into depth with the JSON creator, which you should follow and use, very much so. So, we don't actually know what we want to put here. I will say, you know, clearly we want to get player, and let's see what functions it has. It has init player. So let's you know, make sure to init the player. Now, we haven't actually, I've already defined this. So if we go over to player, we're going to see there's also a constructor. So we're going to start filling this out. So this constructor just calls init player, passing in every single one of these. Width, height, sprite, transform, has fizz, and body. So this has physics one is important because we actually do implement a thing for having physics. That is very important. Now, if we want this to look nice, we're just gonna do that. Here, we can even make it look nicer. You can do it like this. There we go. That's nice. So we go over here. Control Enter, Tab. There you go. That looks nice. So we're gonna store our references to the components. Now I didn't go over here. So in here we have a whole bunch of stuff. So this define, if you remove this define, none of these exist. These stop existing. These stop existing. Because if it's not a top-down game and it's a side scroller, do you have attack up or walk up, walk down? You can have attack up and attack down, but in this case, the assumption I'm making is that there is no attack up, attack down. I'm assuming jumping or hitting them with your head is attack up. So, and then if it's not defined, it goes. I'll explain all of this like math and like weird stuff in a bit. But like, so in here we have, are you moving? Are you attacking? Is the player locked from moving during this animation? Because when you're attacking, you know, you shouldn't be switching into your moving animation during your attack. Especially not in a 2D game. In a 3D game, you can do like animation blending, but it's much harder to do in a 2D game. But so we're going to have a reference to our sprite, a reference to our animation controller, and a reference to the player transform. And then if you have physics implemented in this body, a reference to the physics body, and obviously this needs to be true. And then this is the default animation direction. So this will default to left, right, up, down. It really depends on whether or not you have this. This will help you. I wrote this to help you. Technically, you could just delete these when you're doing a side scroller and write all your own stuff. Just make sure to do whatever makes you comfortable. So we're going to store references to our components. So here we'll start with equals sprite. Now you'll notice this is part of the reason why we use M. So now I can differentiate the anim controller from the member anim controller. Oh, sorry, I called this one controller. So then I can differentiate transform from transform. And then if has physics, M physics body equals body. There you go. That's all. So the first thing that we want to do is initialize UVs. So I can't really explain what UVs are, so just take my word for it. They're like, so go into, if you go into paint and like the UVs are those, this is a UV box. So there are corners and the UVs are just store the corners. So what we want to do is store all the corners. We want to just initialize the UVs and like make it so that it can run, so that it can texture everything, and so it's ready. So loads the texture. And height. So msprite, load sprite, file name, width, height. So does it have an animation? This is a thing that we haven't actually checked out from our load sprite. We've never done this. So is it animated? Yes. Where's its animation controller? So we pass it controller. Or sorry, pass it manim controller. But technically you could also pass it controller. But it's better to pass it manim controller because you want to like keep those organized. So manim controller set VAO. I'm not going to explain what this is. Just trust me and write this. manim controller set texture size. So this just basically makes it so your anim controller lines up with everything with your sprite. And that's all. This, now we're going to load in the animations file. Now this is a JSON library that just allows us to load in JSONs. Now a JSON is just like, it's an organized text file. That's all. That's all it is. It's just an organized text file. So now I'm going to start sectioning things off. Idle animations. Now be careful and make sure to keep this space here. So I don't know if you know this, but if you do a backslash, it makes the next line a comment. So I just do it for formatting to make it look cool. You don't have to use a backslash though. So idle left. And so what we're going to do here is actually we're going to use those. We're going to use this thing right here. Alternatively, you can always just remove the idle up and idle down, but I'm making a top down. You guys are making side scrollers. And the whole point of that is to make it so that you guys have versatility in the engine, so you guys all learn. So you'll notice that I'm giving it a specific like thing. So .get, oh, I didn't name it animation, sorry. .get animation. That's all. That's all. Now you'll notice I'm doing a specific thing. And if we go to the configs. I am currently opening up the configs. Oh. There you go. So Alt Z. Ooh. Interesting. My Alt key isn't working properly, so I have to go into View. I do need to restart my computer at some point. But you'll notice that if I search idle left, you will find all of the data for idle left. Beside it, you will find all of the data for idle right. There you go. Oh, I went way too far. For idle right. And then idle up, and so on. And idle down up here. You'll notice that each and every one of these, so if I search the word idle, there's 4. If I search the word walk, there's 4. If I search the word attack, there's 4. And so that makes sense when you consider that there's 4 of these. There's 0. So this offsets it at 0. Moves it over to 4, moves it over to 8. Now technically, I'm going to show you guys something cool, basically like with automation, that just makes it so you guys don't have to write a bunch of code. A bunch of repeat code specifically, because repeat code is the worst. So this is idle left, idle right, and this is not going to be fun. You obviously don't want to write this. Theoretically, you could actually modify this so that you can send in a vector and just loop through the vector until you're done with all your animations. So you could do like for I is less than animations dot count or dot size, and then I plus plus, and then inside of it it's anim controller dot add animation animations, and then animations, and then and then it'll give you like, sorry, animation names. Names. And like, and then you just do dot get, and so on. So, yeah, it's like dot get animation. Get, and that. And that's it. And you just write this over and over again, and you just pass animation names to the thing. And this one loop would add in all of the animations that we're about to add. It would remove the need for any repeat code. But I'm doing this so you guys get practice, because this is important. Practice is very important. This returns an animation. So then idle up. And you'll notice we're doing this in a very specific order as well. Add animation. Idle up. Dot get animation. Idle down. Oh, I forgot the other pointy brace. And now it's attacking. sorry, it's walk animations. Walk left. Walk left. And then walk right. And then walk up. Walk up. Animation. And then a walk down. Then we got the attack animations. Attack left. Walk, or sorry, attack left. Get. Now, so what this is creating is a standard. So whenever you make your new like player characters animations, you want to use these exact same names, because this way when you load in the same, like a different JSON, all of your JSONs will have the same naming conventions, and you can totally just make a completely different like sprite all of a sudden without any changing any code. You can make a completely different sprite be your main character, your player character. Like you could turn an enemy that you have all these animations for into a player character, which I think is very important. Like it's modularity, and that will help you a lot in the long run. This way, if you ever want to change like the focus of your game, like for example, in my first year, we had to pivot from a 1-player experience to a 4-player experience because we made our game multiplayer at the end. And so in order to do that, we had to change a bunch of stuff. And write a whole bunch of new algorithms that would work for 4 people instead, because not all of our stuff was fully modular. And that's because we were first years, obviously. It's not expected that everything you make is modular. But you should always be aiming for modularity when you write code. Tag down. And then set animation. Oh, sorry. Still in coding mode. D animation. So what did we set our default as? So left. Idle left. All right, so now what we're gonna do is in our update, you'll notice we have a movement update and an animation update. So if the player is not locked, movement update. And then regardless of if the player is locked, we're still gonna do our animation update. Okay, so movement update. So we're going to be writing 2 different versions of movement. we're going to be writing two different versions of movement. Now, we're going to be writing basically what we have if we go back to first creation.cpp. So you see this movement, this stuff. We're going to be basically writing this. So honestly, we're going to do a pro gamer move. And I know at this point I've been teaching you guys to write all of your code at the same time. You know, don't do, you know, don't make any skips. But honestly, you can. So the whole point of programming is program smarter, not harder. The more code you write, so we've already written this code. Now technically we could create a function that would just call this code for us. Simple movement. So our M transform is a pointer. So we need to change all of these to pointer symbols. Because it gets mad if we don't. And then we need to write M transform, M transform, M transform. So now we've got all that. So we've got regular movement. But again, we've already written if they have physics bodies. So if M physics body, or honestly, if has physics, because we do not actually store it. So M has physics equals has phys. We should make sure to write that. I didn't even realize we weren't storing that. So if M has physics, if the body has physics, if you passed it a physics body in the beginning, we're going to write a different set of, and then this is else. So we're going to do here, we're going to manually put that into an if statement. So there's another thing that we have though. Now if you remember, so the whole point of this one is we're bringing together all of the stuff we've already written. So if you pay attention to what we have written down here, you know, we have all this. So we can just copy this. Bring that in here. Oh, sorry, in here. Sorry. So we already have physics-based movement, so we can just do this. We can delete this. So speed. And now remember last time how I told you that there was another way to do this stuff? So we're going to do it the other way, the one that's been fully implemented, that just uses, that doesn't require you to get the body. So we're going to do moving is false, and remember how we stated that, so this is going to be 0 unless one of these becomes true. So if one of these becomes true, we'll just set it to true. And this all happens in less than a second, so it won't actually really affect anything. This all happens in less than like less than a millisecond, I believe. Depends on how slow your computer's running also though. So we can do velocity equals velocity plus, and then, so the whole point of this is just to show you that there's another way to do these things. You don't necessarily have to do it this way. So 0.f, 1.f, 0.f. Now at the very end, you'll notice that our mphys body dot set velocity times speed. That's all. So I'm moving equals true, and then we just need to set these up. So minus equals to, or velocity equals velocity minus vec3 0.f, and then vec3 velocity plus, oh sorry, all of these are velocity plus, that actually turns into the exact expression as this. And then 0.f So now we've got physics movement and other movement. So there's another thing that we still haven't done. So what we're going to do is we're going to move this up here so we don't have to have much repeat code. So moving is false by default. And so what we're doing, moving equals true. So I don't know if you guys know this, but a bool is just 1 bit. It's very small. I believe it's 1 bit. Someone can correct me. A bool is a 0 or a 1. That's all it is. It is a 0 or a 1. It is not very expensive to switch bools. That's why state systems in a lot of current games use bools for everything. Well, not everything, but they use bools to define whether or not you're going to change states. Like, are you going from running to climbing? And you'll actually learn about those in 3rd year. So one thing you'll notice is we also have this magical thing called our direction. So we need to be facing specific directions. M facing down. M facing equals left. And then M facing equals right. And then we just got to do the exact same thing. M facing equals up. M equals down. M left. M facing equals right. Now just remember that there is no, like, you don't need to stop a like regular movement. You do need to stop this because this is just manually setting the velocity. This stops itself though. As long as none of these never trigger, velocity is 0. And then, you know, obviously we still have our speed up and shift, you know. Now, we also have an attack animation that I mentioned earlier. So input get key down, key space, M moving, false. So it'll stop you from moving. If it has physics, mphys body, set velocity, and this will just set it to a default 0 vec3. And then M attacking, true, and then M locked equals true. So that's important. So this will take us into the attack animation. Now, because this is controls, I put this in movement update. But this bool will allow us to enter the control. You know, we're gonna set this one up first. We're at just about 55 minutes, and we are almost done. Thank God this one is less than, you know, a couple hours. But this one I just set active animation. This is just a wrapper for this function, so that you don't have to like do .get, you know, .m animation controller and then .set active animation, because it's just annoying. So int active animation equals 0. So if you're moving, so we have those categories that I created. So walk category, walk. So if you're attacking, active animation equals attack. We're also going to check here if the attack animation is done. So if, and there is an actual function for this, anim controller dot get animation get active anim. This just gets the int for the active animation, and then get animation done. So is this animation done? It'll auto set it to idle. Set to idle. It's no longer locked. Resets the attack animation. So .get animation .reset, and then active animation equals idle. So this forces into the idle animation. Now we also have this, so if it's not moving and it's not attacking, then it means, in this specific case, active animation equals idle. So there is, so if we go back to player.h, we'll look at these. So if we look at animation types, so there's idle, walk, attack. And so idle starts at 0, idle is 4. So what we just did here when we write walk is that it evaluates to 4. So active animation is now equal to 4. Now if we go into player.h and we look at the directions, so left is 0, right is 1, up is 2, and 3 is down. So if I do idle plus left, so 0 plus 0, idle left is 0. So idle right is 1. So if I do idle plus right, that's 0 plus 1, that's 1. And that's idle, that creates this. If I do idle plus up, that's 0 plus 2. Look at this. Idle up is equal to 2. And so if we go to walk right. So walk right is equal to 5. So if I go to walk, that's 4. And then right is 1. So 4 plus 1 is 5. And look at this. Walk right is 5. And so what I've created here is, what we've created here is a system that just allows you to super quickly do this. So all you've done is set your active animation category. So now we just set active animation to active animation plus, and then we cast it to an int, and then we take the direction that we're facing. And that's all. That's everything. That's all. The last thing that we just need to do a few more things before we're done. You'll notice that we already have movement in here, so we don't need to add movement at all in our keyboard functions. So, but you'll notice we never filled out this. So we need to fill out this. So that is file name, animations. We want it to be 20 by 30 because it's a small sprite. It's linked to the past, so it's meant to be small. get component, entity, controller, and we're gonna move to the next line. ECS, get component. Oh, sorry, I forgot the and. Transform, entity, has physics body, false, and that's it. That's all. Oh, sorry, we don't even actually need has physics body, false. I have it defaulting to false. So that's all we need. Honestly, just gonna do this. There you go, that looks better. Now, we just have to do one last thing. Get component, transform, entity, set position, 2.f. And then the very last thing we need to do is a thing that we do every single time we have the scrolling. So get component, horizontal scroll, main entities, main camera. Make sure to pay attention to this. Make sure that you're writing main camera. Get component, transform, and make sure you're writing main player here. And then we can just Control-C, Control-V, change this to vertical scroll. And then as for the very, very last thing that we need to do, auto and player. So we just need to get player. We really shouldn't be doing this here, but this is just quickly. You should make like a variable. And I will show that in a second once we finish writing this. So I just grabbed the main, I don't know why I wrote main entity. Main entities, player, and then player.update. And update just does all that stuff that we wrote in here. Update just makes sure to call these. And that is it. Now, if we go over here, I've already added this to our scenes header. It's in here by default. So if we just go and then we switch this over to 2. Waiting. Oh, we have a JSON error. That's interesting. It's an init player. So let's go to the name of this, check it out. Let's try hard coding this, because I know that that is the name of the file. So it's possible that we might have just written it wrong. We did write it wrong. Why is that running? Oh, if has physics. Silly. Okay, so we got to go back to player. This should be... So notice how when we tested and threw in our, like, you know, that's one way of debugging. So you can throw in the actual value that you want there. So you'll notice I screwed up. The name of the file is not link animation, it's link animations. Now we can run it, and we are just over an hour. Oh, we are getting a lot of errors. Link animations.json. Interesting. Weird. But this is a teachable moment. It's weird that we're getting these errors. Wasn't getting these before. Because I've tested this, but this is a teachable moment, so we're going to learn how to debug. We're going to do some more debugging time with Nick. So let's go here. So it does not like the name of this. Oh, I was... This is what I meant to put here. I'm sure some of you guys caught that. Good on you if you caught that. I did not mean to put animations. I meant to put animation JSON. So you'll notice, idle left, walk right, down, up, attack, attack. And you'll notice link compresses and moves. And the reason for that is that thing that you will learn about in those PDFs that I sent. But yeah, and so it even like, so I'm holding down. So if you face left, it'll always like, choose the left and right facing over anything else. The last things that we want to do is if we go in here, or not in here, sorry, it's not in here. So if we go in here and copy this, we just want to make sure to remove anything that mentions up and down. So basically just put that above any of that. And then if top down, so you can't be moving up and down. Now again, you could just remove these. These are just to make your life easy. Oh, I just realized I didn't and if and then that should be it. There should be no way of going into the facing direction of up and down. So this should all still work. Nothing should have changed. So we can still go up, down. Everything still works. Now, if we were to go in here, here's where it gets fun. So if you remove that hashtag define, go in here, you will find that you cannot go up and down anymore. You also find that these black out and these become white. All the ones that weren't supposed to work. Because there's no defined top down, you can only go left and right. I'm holding W right now. I'm holding W and S. There's only attack left, attack right. Now, all this did was it only imported the animations that were good for side scrollers. So what I've created here is a side scroller. And that's all. I can't go up, I can't go down. Now I could add in a jump that would, like, I could press W and make my character jump, but I don't have a jump animation for Link currently, or else I would, but like a jump, I could just make him move up like a few centimeters and then make him move back down. But yeah. So I've already done part of your thing for you. This I've already adjusted this so that it would work with a side scroller. And keep in mind, I didn't have to change any code to do this. So now I can just do #define top down. And all of a sudden, all of these work again. If I run it, it should all work. That was an IntelliSense. This is an IntelliSense error. That's not an actual error. This is definitely, yeah, see, when you came back to the file. It's not an error that you have. But yes, that is everything for this this lesson. But that is everything. Now I can move back up again, because I added back, it's a top-down scene. That's all. Now I'll be uploading everything along with this video. But if you have any questions, remember to leave a timestamp and your question in the discussion board. And your task is to basically add animation, this animation controller to your physics scene. Make it so it works with your physics playground. And that is all. Just make your top-down scene. Make make it work with your side scroller. That's it. Just add, like, the player and make it work. And create an existing sprite sheet that basically fixes that one issue that we had. That's all. Thank you for watching. Have a great day. Have a great rest of your week, actually. I'll see you guys on Wednesday. Bye.